looking forward to it all day?
I have been, actually. I have been. I had an offer. I don't think so. Not in this class. Okay, so we're talking about partial fractions today. So, okay. You've been used to factoring forever now, right? So if you have a, x squared plus 5x plus 6, right? You can break that down into its factors and basically write it in terms of its factors like this. So basically, when you do that, what have you done? You've broken it down into simpler functions or expressions from which this one is composed, right? Composed of. So we know how to do this almost instinctively. We know how to break it down and express a polynomial function as a product of linear and quadratic functions, right? So we can do that for polynomial functions. Well, it turns out rational functions can also be written as the sum of two or more simpler rational functions. So just like I wrote this as the product of two simpler functions, I can take a rational function and write it as the sum of two simpler fractions from which the bigger one came, okay? These simple rational functions have real constants as their numerators, and their denominators are a power of a linear factor or an irreducible quadratic factor. We're going to get into it. So take a look at this example here. I have here x plus 13 over x squared minus x minus 20. I can break that down into this fraction plus this fraction, right? So going backwards, if I added these two fractions together, magically I get the one on the left-hand side. So that's what we're going to do in this section. What we're doing, okay, to get technical, is we are going to decompose this fraction into two partial fractions. So this whole process is called partial fraction decomposition, all right? So if you're told, decompose this fraction or write the partial fraction decomposition, that's what they're telling you to do. All right? I've broken this lesson down into the different cases that we can come across, and those cases are classified according to their denominators. Yes?
I don't understand why the
first case is, so this is case 1. It's if you have a denominator with linear factors, okay? So like this one. Okay. What we do first is I'm going to rewrite this here. Okay. I'm sorry. I didn't mean to rewrite it exactly. I'm going to rewrite it, but factor the denominator. So if you factor the denominator here, we get x minus 5, x plus 4. So do you see that when you factor, you get two linear factors, right? Okay. Now, this fraction can be decomposed into two simpler fractions. Why two? Because you have two distinct factors here. So I can decompose it into fraction A and fraction B. So two fractions. Each will get one of the denominators. Now, so do you see how if you were to add two fractions like this, the common denominator would be x minus 5, x plus 4? So this, right? So we're just going backwards now. Now, the numerators are going to be constants. So I put A and I put B. All right? Convention is capital letters. keep it as capital letters. I think it's like bolder to see. If you had 3 fractions, it would have been A, B, C, and so on and so forth. Okay. Now what we're going to do is we're going to multiply by the LCD and solve for A and B. So multiply by LCD and then solve for A and B. And there are, many ways to do it. I'm going to show you like the more efficient ways to do it. Okay, so multiplying by the LCD, x minus 5, x plus 4, x minus 5, x plus 4. Remember, what you do to one, you have to do to all of them. I switched that one over there by mistake. It's fine. Okay, so everything here cancels. X minus 5's cancel here. X plus 4's cancel there. So let's just see what we have left. X plus 13 is equal to A times x plus 4 plus B times x minus 5. Okay, now we're going to plug values in here for x in order to get 2 equations and eventually solve for A and B. You can plug in any value you want, -7, positive 243.2, whatever you want. The wisest choice is to plug values in here that will make one of the parentheses 0. Okay, now let me ask you this question. How many unknowns do we have?
2.
2. So you need to have that many equations. It's A and B. We have 2 unknowns, A and B. So here's what you do. You plug in values, okay, preferably ones that make parentheses equal to 0. Okay, what do I mean by that? Let me tell you what I mean by that. What would make this 0? 5. So I plug in x equals 5.
Did you say doing one that would this one that's exacted is better than doing one that doing one that's a positive number?
We're gonna do both. Let me do the whole thing and then you'll see what I'm talking about. So x equals 5. Here I get 5 plus 13 equals to A times 5 plus 4 plus B times 0. Okay, look at what happens magically. That goes away. 18 is equal to how much? 9A. So how much is A? 2. Isn't that cool? It is kind of cool.
So you chose 5 plus B because that would make...
I just chose 5. Right. That would make that... Okay, so now, what would have made this 0? -4. So let's choose -4. And then I get -4 plus 13 equals A times 0 plus B times -4 minus 5. So here I get 9 equals -9B. Okay? So B is -1. Yeah. It's totally fine. Then you would get like a system of equations and you would have to solve it. So you would get like A plus B equals 7, 2A minus 3B equals 2, and you can solve it. This is the best way to do it. You can always do it this way. Yeah.
How about like if there's like a C then?
Okay, so let me do this whole lesson, and I promise I've put in here an example from every single possibility. Okay? All right. So now A is 2 and B is -1. Okay? So now I need to write this. Okay, so I say this is equal to. I need to go back and put these values into here. A belongs to the fraction with x minus 5. So I say that is 2 over x minus 5. Okay? And then the other one, so it's plus, B was -1 over x plus 4. Except in Precalc Honors, we don't do plus -1 over something. We just make this a minus here. Okay? So this is the partial fraction decomposition. That's what it is. So now if you added those, you would get that back. Okay, yes, question. Case number 1. Now, what if you have an improper fraction? Okay, what is an improper fraction? If the numerator has a degree that's equal to or greater than the denominator, then that's an improper fraction. And what we're going to do is use long division first to rewrite the fraction. Okay? So look at this first example. I had x over x squared. The numerator has a lower denominator. That's a proper fraction, like 3 over 4 and so on. Here, though, x squared over x squared, that's an improper fraction. So first we have to do long division. But you know what? It's these don't take too many steps. You're usually done by like 1 or 2 steps at the most. So this one, x squared minus x, is going to be divided into negative 2x squared plus 9x minus 4. Okay? All right, so this divided by that is negative 2. Negative 2x squared plus 2x. And remember, I change the signs and I add. That's the same as subtracting. 7x minus 4. Now, look at this remainder here. I have 7x. That has a lower exponent than the divisor. I stop right there. Okay? So, we stop when remainder has a lower degree than the divisor. Okay? All right. So the divisor in this case is x squared minus x. Okay, now, what have I done then? This fraction now can be rewritten as negative 2, that's the quotient, plus 7x minus 4 over x squared minus x. Remember from Algebra 2 and from chapter 2, that's how we rewrite that. Now, this part is the one you're going to decompose.
And then what do you get from negative 2?
You just tack it on at the very end. So now we're just going to decompose that one. Okay, same process as before. 7x minus 4 over, I factor the denominator. Okay. Now I split it into my 2 fractions. All right. Underneath I get x and x minus 1. Those are the 2 terms. And then check. Will the common denominator of these 2 be x minus 1? Yes, it will. So we're good. In the numerators, I put a and b again. Okay. Multiplying by the LCD. The LCD.
That side doesn't give you anything, right?
But it does, because you want to make all the denominators go away. Plus, you can't multiply something to the left side of the equation and not the right side, or vice versa. So here the x's go away.
If you're going to combine the denominators, you could
if you're just adding, yeah. Okay, so here 7x minus 4 equals a x minus 1 plus bx. Okay, what numbers can I put in here? 1. So when I put in x equals 1, I get 7 minus 4 equals a times 0 plus b. So how much is b? 3. What else can I put in, guys? 0. So 0 minus 4 equals a times negative 1 plus 0. So negative 4 equals negative a equals 4. Now, when I'm going to put it all back, you've got to bring back the -2. So this will be -2 plus a over x, 4 over x, plus 3 over x minus 1. Be careful. Either. It's normally put at the beginning. It's convention, but there's no rule against it. Be careful that you match, the value for a with the fraction, that you use a for. So don't put the a for the x minus 1 and vice versa. Yeah.
Can you just put a back in, like, to the problem instead of putting b, like, to the 1?
Yeah. No, because then you have your x's there. So you want to eliminate the x's. Then you'll have a and x, like b and x left over.
Okay.
Yeah. Okay. Next, okay, so this is case 2. This is case 2.
The other one was not case?
No, the other one was still case 1 because you still had it's like case 2, italicized I, Yeah, case 1A, case 1B. Okay. Case 2, now you have denominators with repeated linear factors. So remember, they get differentiated according to the denominators. Denominator with repeated linear factor. Okay, what does that mean? Well, here is what it means. I could read the description to you that I've written, but I'm just going to go to the example. Look at this. In factored form, instead of having x times x minus 1, I have x to an exponent and x minus 1 to an exponent. Do you see that? So in terms of multiplicity, it's when the denominator, it's when these terms have a multiplicity other than 1. All right? So look at this one. When we factor, each of the factors has an exponent of 1, right? Here, the factors have an exponent higher than 1. When you have that, all right, what you're going to do is whatever exponent each term has, you need to make that many of that term. So if this x has an exponent of 3, then you need to give it 3 fractions. And if this has an exponent of 2, then you need to give it 2 fractions for a total of 5 fractions. Okay? So, one more time. This has an exponent of 3. So look at what you do. You do x to the 1, x to the 2, x to the 3. This has an exponent of 2. So you do x minus 1 to the 1, x minus 1 to the 2. You always increase it. Yeah, you start from 1 and you increase until you hit the maximum exponent. Yeah.
And that's when the factor denominator goes with the factors have the multiplicity of 2.
Yeah, whichever one has a multiplicity of 2 or higher, you have to increase factors. Correct.
I have a question.
Yeah.
But if there's like a 2 to the left of the x cubed, how would that change anything?
It wouldn't. We're not dealing with that. Then you just take it out. Yes.
On the test, will there be like a combination of 2 different cases or just one case?
There isn't. No. I mean, listen, if this had like an x times x minus 1 squared, you give 1 for the x, and then you just repeat the ones that have an exponent higher. Okay, so look at this. If you were to go back here, if you were to add this, what would the common denominator of all of these be?
X cubed,
x minus 1 squared. You see that?
Why is D x minus 1, but then you have an x minus 1 squared?
Okay.
There are only 2 of them.
For each one, if it has an exponent higher than 1, then you write that denominator to the 1, and then you increase its exponents until you hit this number.
So that was 1.
Yeah. Okay, so let's do this one now. Let me factor this. This will be x squared. This will be x times x squared minus 4x plus 4. Okay? So let me write it in factored form. 3x squared. Don't write too big because we're going to need all the space for this, okay? Minus 5x plus 4.
So would there be like one of these problems or one of the other one?
Well, now that's
But I really
too
don't
much
know that.
information. Okay, so x, there, you're definitely going to have some partial fraction decomposition, but I can't specify which ones I'm going to give you, okay? Okay, so here it is in factored form. All right, now take a look. Look at this x. It's got an exponent of 1. How many fractions do we give it? 1. Plus x minus 2. What's the exponent? 2. How many fractions does it get? 2. I have x minus 2 to the 1, x minus 2 to the 2. Okay? All right. Okay, yes.
Do we always have to have the exact same, like, let's say we
Yes, the
start,
same power. Yeah.
No. You know how you have A, B, and C? Is it that?
3 fractions, we just go A, B, C. It doesn't matter what you put. You could do, I don't know, happy face, sad face, crying face. It doesn't matter. Just placeholders, okay? Now, same process as before. We're going to multiply by the LCD. Okay? LCD. Everything cancels from the first one. Just x cancels here. 1x minus 2 cancels there. Both x minus 2's cancel there. 3x squared minus 5x plus 4. Best advice I could give you here is be neat and ordered and organized so that you don't lose track of these terms. Here I have a x minus 2 squared, b x minus 2, c x. Okay? Let's plug in some numbers. What do you guys want to plug in? X equals 2. Okay. This left side gives you 6 equals a times 0 plus b times how much? 0 plus c times 2. So 6 is 2c, c is 3. Yes, 1 down. Okay, now, what other one do you guys want to plug in? 0. The left side gives you 4. A times 4. B times 0. C times 0.
A equals 1.
A equals 1.
But how do you cancel B?
Okay, now we've run out of numbers.
Yeah, can you just plug in any number?
You can remember what I said at the very beginning. I said you could have plugged in like negative 72.2. So now you could plug in any number. You could have always plugged in any number. We just made the wisest decisions that would give us lots of zeros. So I'm going to plug in 1.
Yeah,
Just because I've already done that and I've done the math. Okay? So 2 equals a times negative 1 squared plus b times negative 1 plus c times 1.
Is 1 the next best option to put in?
That's strictly choice. 1 is just an easy enough number that when I square it, I just get 1. So here, what do I get now? A minus b plus c is equal to 2. But I know what a and c are, don't I? I do. 2 is, what's a? 1 minus b plus 3. Okay? So how much is b? 2.
Why is it that for B, that for extra 1 in the B, why is it B times negative 1?
It's here. We plugged 1 in here. So it's b times 1
Oh, okay.
and then negative 1.
So it's 1, 2, 3.
Huh? That's 1, 2, 3. Haha. That's so cool. Okay. So again, don't mess up the order, right? So it's going to be 1 over x plus 2 over x minus 2, 3 over x minus 2 squared. B is positive too, because you get 4 minus b. Yeah, well, I mean, you get 4 minus b equals 2, and b has to be 2. Okay. Oh my gosh, wait. Are we on the last one? Oh. I wish there was more. Okay.
Yeah, you can start the homework together.
This is case number 3. I could do this like all day.
Case number 5.
No joke. I could do this all day.
I probably will be on doing this all night.
You probably will be, because there are a couple. There is at least one that takes a full page.
What?
Yeah.
Like an entire college
Yeah.
Yeah, there is one that with many, many steps.
So I can say question mark on that?
No. Because then I just get better at it. Okay. So, this one is denominator with prime quadratic factors. Prime quadratic factors. For example, all right, if you have x squared minus 1, that factors, right? X minus 1, x plus 1. But now, suppose you had x squared plus 1, that can't be factored any further. So it's prime and it's quadratic. So all the ones we've been doing so far, we were able to reduce the denominators into linear factors. X is a linear factor to the power 1. X minus 2 is a linear factor. This is x minus 2 quantity squared, but it's still linear. You just have 2 of it. Okay? Now, what if you have a linear factor? What if you have a factor in the denominator which is quadratic and can't reduce? Well, look at this one, for example. You have x squared plus 1. Okay. The x gets a fraction. The x squared plus 1 gets a fraction of its own. But, whereas for the x, we gave it a numerator of a constant. For this one, if it has a degree of 2, its numerator must always have a degree 1 lower. So if this has a degree of 2, if this is a quadratic, the numerator has to have x to the 1, a linear. So how do you make linear? It has to be constant times x plus another constant. Okay? All right. Let me do this next one. So, hang on. This one, it's already factored as much as it can be factored. The denominator. The top is x cubed minus x. We just leave it. Remember, we never do anything to the top. Oh, no. Okay, so now look at what we're going to do here. What kind of denominator is this? You've got a repeated factor. So you have x squared minus 3 squared. That means we need to have 2 fractions. One gets an x squared minus 3. And the other gets an x squared minus 3 squared. Now, if this is a quadratic factor on the bottom, the top has to be some sort of linear expression. When we talk about linear expressions, you always think of y equals mx plus b. That's how you get a linear, like that's the generic form of a linear equation. Mx plus b. What does mx plus b look like? It's got basically a variable x. All right, so it's got a constant times x plus a constant. But we're not using m and b, we're using a, b, c, d's here. So we have to have a constant times x plus another constant. Okay? The next one is another quadratic, so we need another linear. So what are we going to do? Constant times x plus a constant. I already used a and b. I go to c and d. So constant times x plus a constant. If you had another one, ex plus f. If you had another one, gx plus h. If you use a here, and then you have bx plus c. If you had another one, dx plus c. You're gonna, that's the one, like your homework, yeah.
So doesn't the exponent of the denominator determine
Yes.
the constant you have on top?
Yes.
So
You're not gonna have an exponent higher than 2 though, for us, in the bottom.
so
This is
you're
as
having
complicated.
constants on top.
This is as complicated as we'll take it.
Oh, but it could be ax squared.
It could be anything, yeah, sure, it could be anything, yeah. Okay, now, same process as before. Okay, multiply by LCD. Everything cancels here. 1x squared minus 3 here, and everything here. So now I have x cubed minus x equals, oh, this is a fun one, ax plus b times x squared minus 3. Remember, this is being multiplied by that whole thing, so you need parentheses here. This is number one common mistake on a test. Plus cx plus d.
Should we multiply these together?
Now we're going to multiply them. Okay, we're going to multiply these two. So we get x cubed minus x equals ax cubed minus 3 ax plus bx squared minus 3b plus cx plus d. Huh? Okay, now what you're gonna do is you're gonna group by degrees of x. Okay, by powers of x. So what I'm gonna do is this: x cubed minus x. Okay, and now what I'm gonna do is ax cubed plus bx squared. So I'm going to write it in decreasing order of the exponents of x. And then where are my x's? I have negative 3ax plus cx minus 3b plus d. Always count to make sure all your terms are accounted for. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Now, here's what we're going to do. If you have two terms with the same degree, factor them. So, one term with an x cubed, leave it alone. One term with an x squared, leave it alone. Two terms with the x, we're going to factor out the x. But here's how we're going to write it. So, here it's going to be x cubed minus x equals, I'm just going to copy down the first two terms. Now here, factor. What can we, okay, we're going to factor out the x. And if I factor out the x, what do I have left? Negative 3a plus c. So the way I write it is plus negative 3a plus c times x. Like that. Do it, trust me. Just do it like that. You can do whatever you want. I like to do it this way. And then, so then I have plus negative 3b plus d. So what I've done, x to the 3, x to the 2, these have a variable of x. These two are the constants. So you know how when we have polynomial functions, it's like 3x squared, 3x cubed plus 2x squared plus x minus 2, right? You have your x's and then you've got a constant. This together is the constant term. If you don't put the negative 3b plus d in parentheses, it's not a deal breaker. I'm just doing it so that it's visually more apparent. Okay, now here's the fun part right here. What we're going to do is we're going to compare coefficients of like terms on the left and on the right. Now, what we're saying is this equals that. Is that correct?
Yes.
That means whatever coefficient these terms have, the corresponding ones here must have the same coefficient. So here's how I do it. This is the x cubed term on the left. This is the x cubed term on the right. On the left, what's the coefficient of the x cubed term? 1. What about here?
1.
A. You set those equal to each other. So you say 1 equals A. So to write a note for each other, compare coefficients of like terms and set them equal to each other. Yep, so A is 1. 1 down. Now, x squared on the right in the green, what's the coefficient? On the right, the coefficient is b. There is no x squared here. It must mean that its coefficient is 0. So there was a 0x squared, which we are omitting. So 0 equals b. Okay, what about c? Coefficient on the left is negative 1 for the x. Coefficient here is that. So I say negative 1 equals negative 3a plus c. Right. No, we're lucky because we already know what a is. So negative 1 equals negative 3 times 1 plus c. We know what a is, right? We just found a? So I can plug it in there. So c is how much? 2. This is the constant term. Okay, what's the constant on the left-hand side? 0. So I say negative 3b plus d is equal to 0. But how much is b?
0.
Plus d is equal to 0. So how much is d? 0. Okay, let's put all this together. Let's put all this together. I have my 2 equation terms over there, fractions. So,
Isn't it x over x squared minus 3 plus...
Okay, hang on. So, ax plus b. A is 1, so 1x plus b is 0 over x squared minus 3. Yes, we're going to simplify it. Plus cx plus d. 2x plus 0 is that. That's it. No. So now we just write it in simpler terms. So x over x squared minus 3, 2x over x squared minus 3 squared. And there you have it. Okay?